The complete counting circuit displays a single-digit number that counts up or down using a plethora of integrated circuits, or ICs for short. Here are all the parts used. You can pause the video if you like. As shown in part A and B of the counting circuit, NAND gates combined with resistor-capacitor pairs are arranged to form the NAND gate oscillator that produces a true square wave. However, instead of using an LED as the output of said square wave, a 4017 decade counter is utilized, the first specialty IC. This counter sequentially outputs a high on output pins 0 to 9 every time the rising edge on a clock signal is detected, allowing the circuit to appear as though it is counting. The reset pin can be utilized to limit the range of counting by tying the desired output pin to the reset. There is also a divide by 10 pin, outputting a high for the first half of the count and a low for the second half, as shown by the green LED. This equates to a clock signal frequency 10 times the length of the original. In the next circuit, this divide by 10 pin is wired to the clock input of the next specialty IC, the 4516 binary up-down counter. This counter behaves the same way as the decade counter, but instead outputs a 4-bit binary number as shown by the LEDs. The binary number can either count up or down depending on the state of the up-down pin, and the number it starts from can be preset using the input preset pins to count up or down from it. However, many people can't read binary, which is why the 4511 binary decoder paired with a 7-segment display is used to present numbers 0 to 9. This 4511 binary decoder converts binary inputs into certain output patterns that display the translation on a 7-segment display. The output pins labeled A to F correspond to the input pins A to F of the 7-segment display, making wiring straightforward. Since the 7-segment display is limited to single-digit numbers, the 4516 must be replaced by the 4510, which only counts up to 9. If the count is any higher, the display will blank out. The counting circuit can also be extended to 2 or more digits. By utilizing the carry-out and carry-in pins on the 4510, multiple 4510s can be paired with individual binary decoders and 7-segment displays to allow it to count way past 9. Overall, the counting circuit introduces the fundamentals of counting and display in our everyday digital devices using analog components.